Thank you. All right. Okay. Does everybody have this up? Anybody not? Okay. The other question I meant to ask is how many of you have had to learn AutoCAD or doing sort of drafting? Is that everybody? Okay. And Rhino, if you're not familiar, is very similar to AutoCAD. It just has a lot more surfacing tools built in it, but it looks and acts a lot like AutoCAD. There's a command line for typing in almost all of the same commands that are in AutoCAD. If you have used them in the past, they have the same snaps along the bottom when you're drawing stuff. The system is set up also like modern AutoCAD, where there is a set of toolbars broken up by different types of commands. There is also at the top, based on breakout of different types of topology, curves, all of the ways to make different types of curves. And what you'll see is some of the similar, there's only so many ways to make all of this depending whatever software you use. So some of the same types of line creation will show up here that showed up in the digital project. So does everybody have this guy on the left here? Or is that not a standard startup? You guys do? Okay. So again, that's just another place where things are broken out. These are the most common used commands. It looks almost identical to AutoCAD. In terms of some of the navigation, this is a little bit different. If you double click one of these guys, you'll expand that viewport. You can only open one file at a time in Rhino. So the idea, in most programs, Control Tab is the, lets you iterate through different open files. In Grasshopper or in Rhino, it's actually for going through different views. So Control Tab will take you through those. If you click on this little arrow, you get a whole bunch of other stuff. That helps you set what view you have here. Restore will bring you back to that kind of 4-point or four view perspective. In terms of I'm going to go back to we'll just deal with one today. One of the most unfortunate things about Grasshopper and Rhino is they both like full screen, and so we'll have some challenges trying to teach it on this small, but we'll see how it works. In terms of navigation, it's very straightforward compared to Digital Project. Scrolling does zoom. Right click is pan. And it's also, right click is orbit if you're in a view that is not locked to an orthogonal perspective. So this is top, so the right click is panning. If I do Control Tab a few times and go to perspective, then the right click is orbit. So really for navigation, you just need the scroll and the right click. The way that if we grab a point here, single point, and just drop someone, it's going to assume you want it on the XY plane. The scrolling is contextual to where your mouse is. So if you're over on the right side of the screen and scrolling out, it will behave differently than if you're zoomed over top of something. So usually you point the mouse at what you want to zoom into, and that helps you navigate around. In a little bit, we'll give you, there's a similar kind of shortcut that you can do that will let you center your target if you really want to be precise on how it spins. The command, if you want to set it here, so if you drop a few more points on the screen, if you really want to pivot around this point, the command is called zoom selected. And it will start to fill in. Oh, sorry, zoom selected, not show selected. Or is that it? Sorry. Huh. Sorry, I have this as a shortcut, so I can't remember anymore. There we go. All right, there it is here in the, and that will set that as the center point. So as we get a little bit more complex, you'll be able to use that. All right, so in terms of parametrics, none of this is parametric. All of these points, when you guys select items, are you getting this kind of multicolor business, or is it not? If you are, great. If you're not, you have to turn on this thing called gumball. I think you just click it contextually, and what that gives you is just a more precise way to manipulate items. If you are in, if I control tab to top view, it's going to constrain it so that it's only moving in the XY plane anyway. But even though what we're doing here, it's very flexible, very adjustable, it's not parametric. If you draw a line command, and this is kind of the quintessential Grasshopper example. Yes?
Right-click, shift, the only way to pan in perspective mode?
Yes, and I think there's a couple different combinations that yeah, so control is zoom, shift is pan, and then there's I can't remember what it is, but there's the shift alt is sort of precise rotation. Just normal right click is sort of free orbit. If you want to just rotate the view, I don't have it here that I care, but if I wanted to just rotate it kind of about the y-axis, you can hold shift alt and it will just more precisely rotate around the as if you were turning the camera rather than moving the camera. But the example you'll find all the time, because this is the way the developer of this software, of Grasshopper, his name's David Rattan. And he's famous in that he answers about every single person's question on the Grasshopper forum. So he's apparently not programming all day, he's only answering questions. But he always starts out with this example that in AutoCAD or in Rhino, when you draw a line, you can use the if you draw a line with LINE, or it's here as well, you can use it where you're snapping to, oh, it doesn't want to snap. Oh. Is that it? I don't know. Thank you. Thank you. I know I said it last time, but I actually don't know how to use Rhino that well, because I spend all my time in Grasshopper, so apologies for my naivete here, but use the point. And so there's my line. I think those points weren't actually on the XY plane, or maybe they were, but yeah. So there we go. That line is there, but if I move these points, they were only referenced for creating the line. The line is static. It can move. The points are static. So in terms of now approaching this the same way we approached it in Grasshopper, or in a digital project, you start to do that in Grasshopper. So the way you start Grasshopper is you type in the command, and it's Grasshopper. It will fire it up. And there we go. So now you have this whole other UI that is very similar in terms of functionality that you'll find, but a completely different way of using it. It's all built on the same kind of core technology. So you'll find as you start to explore Grasshopper that there's ways of doing almost all the same geometry creation. For this example, let's do a parametric line. And again, you'll find this in the way that most people start their tutorials. So you'll find this over and over. But actually, let's quickly do a quick overview of what you're looking at here. So that in terms of vocabulary, this is the canvas. This is where you're going to lay out kind of your formulaic geometry. It's analog and digital project is the tree. This is where you're going to store and place all those kind of logical components of your building geometry. In terms of everything else in here, there is another toolbar that's broken up by functionality. The main items that we'll use, because your guys keeps going even further than mine, the main ones that come with default Grasshopper are the first 7. So parameters, math, set, vector, curve, surf, mesh, intersections, and transforms. I guess that's 8. But everything else down the line is an add-on. And we'll talk about that later in terms of kind of community and ease of developing tools. So I think, do you guys, the ones in the other lab across the street in Snow have about 50 add-ons. Are you guys, where do you guys stop? Okay. You guys have Lunchbox? Is that a, you guys have Kangaroo? What do you guys have?
Set, vector, curve, surface, mesh, intersect, transform, WB, diva, extra.
Okay. Good. All right, we'll go over, there's a couple of these and we'll see, they may have to install them or you might be able to install them. We'll get to some of them later, that there's some fun stuff you can do. But for the moment, in the first few classes, we just need the kind of the defaults. It's pretty robust there as well. But in terms of what these are and what this means, so if you ever, just as an aside, if you ever listen to David Rattan, the programmer, talk about Grasshopper, he's kind of this efficiency Nazi, or an efficiency meticulous in nature. So there's about 100 different ways to do everything, and lots of layers and layers, and so half of his tutorials are more about how he's added different ways to save clicks, but the way you access a majority of the components that you'll add into your logic is through these trees. A lot of the labels are sort of self-explanatory. He is not, let's see, he's not sure. So there's some weird translations in them, but most of them make sense. But as you go down, so this is the kind of what you see in just the main toolbar is the ones that are most used, most often. The ones that are, when you expand it, it's those plus their name, so you can see what that actual component does. Let's drop a couple of things down here, and we said we'd start with lines, so line falls under curve. You have analysis, functionality. We're going to start with primitives. These are primitive creation. And we'll just start with line. So you click here and the mouse has this icon, and now you can drop in this line, what's called a component, on your canvas. So the way that you figure out your way around Grasshopper is right-clicking. That's kind of the mainstay of how the program hides its functionality, which you guys also had to right-click a lot in Digital Project. When you mouse over, that's also a big part of how you figure out what these things do, because everything is written very compactly. You know, if you mouse over what's the center kind of black indicator here, you get the component. It gives you a little bit of a description of what it does and how it works. This one's orange because it didn't run correctly, because I'm looking over here and it says, okay, this is my start point, this is my end point, and it says they're empty, there's nothing in there, so this didn't do anything. The warning tells you that as well. You can click up there and see why it didn't run. So, but the main kind of concept of all of these components is that they have inputs and outputs, and that the always running from left to right, and it's always going to be doing some functionality. So line is a pretty intuitive one. My input is 2 points in this case. There's a couple different creation methodologies there, and my output is a line. And so let's go ahead and do that. When you right click here on the A, you get a big pile of things, but the one we care about here is set 1 point. You can hides Grasshopper, and then you can select that in the Rhino page. If you didn't have points already on your Rhino screen, it's here. Just click and click, it will drop them in. It's still orange, but now if I look at this, I have the label, you know, one locally defined value reference point. It's showing this preview here. If I do the same thing here and I click over here to select another point, now I have my line. And if you come back and start playing with it in Rhino, even though these are static, the line now is behaving parametrically and follows my movement. So one thing that we can unpack a little bit here is that, yes?
So the red line is moving. What's the black? What's the black line? Is that just the text that remains in?
The black line is the one that I created in the beginning. That was just the static line that I created in the Rhino tools. So I can go ahead and you can leave it or you can delete it. But in terms of that line, you can grab a hold of the endpoints and drag it similarly. You can even do things like scale and all the things, or trim, some of the stuff you do in AutoCAD, but it's not going to be part of some logic that will build to make something else. You know, it is what it is after you create it. Just to get a little bit of understanding of what we're looking at here, and one of the differences, another main difference between Digital Project and Rhino and Grasshopper is Digital Project is all parametric. From the first point you create to the last drawing you export, it never stops being parametric, and so every single thing you do becomes really heavy, because the first points are that way, the last drawing, everything in between has parameters, and you may adjust them or they may not be adjustable based on the way you created them, but it's all there for you to manipulate. Rhino and Grasshopper is this hybrid. You know, Rhino is static, and you can create stuff and interact with it just like we did here, but it can still operate parametrically. And sometimes that's really nice. You might have, for example, some topography lines that are from the USGS information. That's not going to change. You don't really need it to be flexible once you bring those curves in. They're just going to be an import, and then you can manipulate that in your project. So there's always lots of this stuff that you might start with that's you don't need to change. You're just going to pull in a drawing, something that you've sketched up, and you can use that as a start point. You can also do the same thing where you're creating a point. If you go under Vector, there are point creation tools. So if I come over here and I go to the point module, so I'm under Vector, Point, there's a series of tools for creating and manipulating points. So we can drop in this one. I have a point here. I can right click. In this case, I'm not going to grab something from Rhino to reference. I'm just going to change a value. So my point is, whoops, 1, 0, 0. In terms of navigation, it should be the same across Grasshopper and Rhino. Grasshopper is right-click for pan. There is no orbit. It's all flat. And then the zoom is lets you move around as you create things. Just a little understanding here of what we're looking at. Kind of, as we just talked about, we have the static geometry, and we have this kind of parametric red thing going on and this green thing. So what happens if we saved right now? There's actually 2 files here associated with what we're visualizing. The Grasshopper file contains this parametric information, and Rhino has these 4 points, and that's it. If I actually use kind of my selection tool here, just like you would in AutoCAD, you can click and do a crossing. It's telling me I have 4 points. It doesn't. Rhino doesn't even see all of this red stuff and the green stuff. It's what's called a preview. It's not a physical object in Rhino. So if I save this file, when I open it back up, that's all I'll have is the 4 points. We don't need to do that, but in terms of if I want to save the other part, you still have this other file save. So file save. So the Grasshopper, the Rhino file is called 3DM, 3D model.3dm is its extension. And you'll save that. And these files, even though they're 2 different files, they're linked. So if I were to just open a new Grasshopper file, so has everybody saved both? If you haven't, go ahead and do that. And then just create a new file. As I said before, you can't ever have the same files open. So what this guy did is even though I have a...
I don't think it'll let us save because we have demo versions.
Demo versions of... Interesting. Well, okay. Well, I know they don't down in the other lab, so I'll make sure by next time that this isn't a demo version. But weird. Okay.
We were able to save right now.
You
Class, we just couldn't save the Canadian files.
okay?
So it comes up with a warning. It's like middle here.
Yeah, I mean, okay.
So you can save the .3dm, but not the
Okay, I see what you're saying.
not the mil files
Doesn't mean
associated with.
it'll
Okay.
still save.
Okay.
Yeah.
So I have this new empty file. There's no points in there. And now I also kind of have this orphaned Grasshopper line box. And what it did is it said, okay, well, you told me where you were, and I'll remember that location, but I can't move anymore because that point doesn't exist. I can go ahead and I can re-reference that point here. So the way you do that, again, you just right-click on, say, A, set one point. I'd already had that point selected, so it just assumed that was the one I wanted. If I hadn't done that, it won't even let me do that. And so now I have this semi-parametric again, but I have this orphan again.
Well,
if I go back and I open up the one we saved, points, I just broke it because I grabbed that point that wasn't in this file. So what you find is that these, so go back here and we'll reset A again to the point. So it remembered the one that we didn't change, and then was lost with the one that was referencing the other file. So that the point is that these files are kind of linked together. They know which point in the file. If you opened another file with just 4 points, it's not going to assign to the first two. So even though you're saving separate files, they are linked. And we'll talk about later other ways where you can have it be a little more sort of like a template, where you could have other points and other files and it would work. But they go together. They are a pair once you start to have things link across here. Now what you're seeing here, just to go over a couple other things that will help you navigate the Grasshopper world, the red is the preview. And by default, there are this similar visualization state to every box. If we go ahead and we say we want, we can do a polyline as well. So under curve, so I never can remember where anything is, and there's this lovely function that they have where you double click, left click, double click on the canvas, enter search, polyline. I'll show you there the icon. Still doesn't mean you can ever find it in the crazy toolbars, but most of the time that'll get you what you want in terms of functionality. So here, if we look at our, again, mouse over is the key to understanding lots of this, because sometimes they make sense in terms of the labels that, you know, XYZ, point, this makes perfect sense. P line, okay, maybe, but vertices. So this is a list of points. So in this case, you want to grab, not just set one point, but set multiple points. And click there.
Did you right-click P-line or vertices?
I right-clicked to vertices and did set multiple points. I already had 1 point selected, I think. Hang on. Let's try that again. Set multiple points. Oh, sorry. So sometimes Rhino, because Rhino is the primary owner of this pair. If Rhino is in the middle of a command, nothing in Grasshopper will work exactly as you expected. So you want to be out of there, select multiple points, and you can click on your points. And this is the little preview it gives you of your multi-selection method. Once you're done, so I'll collect those three, hit enter, and now I have my polyline. If I look here under the vertex, the V, now it's telling me I have 3 local values defined: reference point, reference point, reference point. Now on down here, this one's actually, it's another input to the function, but it's not something you need to choose, and from Rhino you can just say closed or unclosed. It all falls in the same place. So for the X values we had set number, because that made sense. For these, they're objects per, you know, actual items in Rhino. And this one is just a true false, and so you can toggle it back and forth. So why are things changing different colors? Why are things orange or red, yellow? Yellow is the default selection color for anything in Rhino. If it's points, lines, curves, they'll all turn yellow when you select them. Red is the default preview color for grasshopper items. And green is the one that is selected, or the multiples that are selected, because you can select these components, and as you select them, they'll turn green in the window. So a couple ways, because as you start to go, we'll start to have that layering of information that we have had in Digital Project, where we start to have too much on top of each other, and we want to be able to manage what we see. And there's a couple of different ways to do that. So in all of the components, we've been looking at the mouse over and the right clicks for the component inputs. There's similar right click and functionality for the outputs, as well as kind of showing you the results. The center panel, the black panel, is the piece that kind of gives you global behavior for that component. So in here, let's toggle this. This is a toggle. So light gray means yes, I can see you in Rhino. Dark gray means no, I can't. Even if I'm selected, nothing is showing up here. The other thing you can do, we won't need this, but you can, if you accidentally get there enabled versus disabled, that's the way that it changes. You know, if you get a fully gray box, it means I'm completely turned off. So the other thing that you can do, so as you start to build out your logic and you have all of the intermediate steps in getting to your finished thing that you want to visualize, you know, in terms of the exercise we did last week with the vaulted surface and the panels, there was a lot of wireframe we drew, a lot of points, all of that we didn't care about in the end, we just wanted that surface. So in that context, you could hide all of your components that are part of the intermediate steps of making the geometry and then just have visualized the end. The other piece that can toggle that helps you with this is right up here. This is kind of your visualization mode. And really, the only thing you guys need to know about is this guy. It's only draw preview for the selected objects. Sometimes, you know, right now, if I was looking for this point, it's hidden. There's no way for me to see it. If I toggle this, so you turn this on, the behavior is that nothing is shown in Rhino from the Grasshopper canvas unless I select it. And then it is shown irregardless of what the preview or hidden state is. So, and you can also multi-select. As your Grasshopper definitions get larger and you need to try to manage the visualization and hide, you can toggle back and forth between, this is kind of, for me, this is the kind of working mode where you are watching how things are going, or this is the, you know, final output. So the last piece that we'll go over here, and this kind of is the real power of Grasshopper, is how you chain these things together and how they link. And you guys have probably all seen this, but these are the, you know, the spaghetti wires of Grasshopper definitions. We made this point. If you guys haven't made a point, it's under sets. Sets has, oops, sorry, vector. Vector has point, construct point. I'm going to actually make another one. So we'll have two. So this one was at 1, 0, 0. Let's put this one at 10, 0, 5. Put whatever you would like. And, preview on for both of those. Wow, very small. Okay. That'll work. So these guys exist. The way that I can now do a function, because I still have these points, they're not parametric. If I need them to be, this is how you link and chain things together. You just left click on this bump coming out of the end of it, and drag it to the input for A. And then do the same here. You grab on there, drag it, and now I have that. I'm going to go ahead and I'm going to move my points in so it'll zoom a little smoother. Okay, there we go. So now this one, I'm trying to select it. It has 0 definition in Rhino. It's completely lives in the Grasshopper canvas. You see the values that are coming in when you mouse over the A and the B. So what you can start to do here is you can also drag and replace. You know, this one takes multiple points, so in order to, if you drag, you know, one and the other to the V, to the vertex, it only does one. You can't do a polyline with just one vertex, so that doesn't work. I'm going to go ahead and you can also copy paste components. I'm going to make one more. So I'm going to copy this guy, Control C, Control V. It copies with the values from the last time, so let's set this at 10, 10. To sequence these together, you hold Shift, and the icon will change. You get a little tiny plus sign. If you keep holding Shift, now you can drag multiple things. There's a couple different tricks. We'll go over that in later sessions of how you manage and move these things around. Sometimes they'll get, you know, you'll have too many of these things running from one end of the canvas to the other. There's the option to, under wire, so it's under right click for the input, you can change the visualization. I'm going to go ahead and say hidden. Changes my icon to this like radio symbol. So you only see the, yes? Yep, right below that. So you can only see them as you move it around here. If you wanted to only do 2 points here, under disconnect, you can disconnect all, or you can go through and disconnect one at a time, and it gives you the preview of which one, since they're all named the same. So I could just do the center one. So that's kind of the basic stuff just to make you dangerous in Grasshopper. Some of the reason we started with Digital Project, in terms of direct analog from what you're making in the tree and the thing that shows up in space, it's a little more intuitive in learning some of the topology, because you can go ahead and you can click on that point in space and it takes you straight into the definition. You can see the different ways from right that point you can change them out. Grasshopper is a little more programmer focused. I think the name of the tool is, it's like algorithmic modeling. So their thought is that you're kind of logic and programming first, almost before thinking about, it's just that the geometry and the topology just happen to be mathematically and computer science based. So it's like perfect for messing around with programming. But so there is a little bit of a disconnect, especially when you get to some of the higher level functions here and how exactly am I using this. But hopefully you'll see some of the similar logic. I mean, there's only so many ways to create a plane, only so many ways to create a point. That's all very similar across this program and other parametric programs. But this is the main way that we start to build the logic, is you have items in, oh, one more thing, sorry. So this is kind of lame too, because this point I can't do much with. You know, it's static. I don't want to keep changing it. So there is one nice feature that lets you explore pretty easily. And this one's under parameters. And in general, the way that they define, I don't know. Somebody told me this after I've been using Grasshopper a long time and I never noticed, but on this end you see the hexagon. In the language of Grasshopper, the hexagon is a parameter. It means it's where you store stuff. The output is the storage there, you know, all this. But the icon of this box is, this component is not a hexagon. There are some items that they're the whole definition is just a point, or just a parameter. So this is for storing things. It doesn't do anything to those. So that's what some of these are. Everything else does something. It's something that operates on geometry or math or strings, or in strings being text in the language they label them here. But go ahead and delete that. You don't need that at this moment. But
What's the difference
Mhm.
between the line and parameter and line under the curve?
so the line is just showing the movement of the information. So
Oh no, there is a line command under the.
oh, sorry, yes, this guy. So this line here. So this is a box for building kind of it's a visualization if I wanted to, for importing lines. So either one or multiple.
But we cannot build a line.
You build it with this line, the one that has the inputs. And you know, even though this has an input, so you can use it like this, where you have a line coming in here, and if I mouse over it, you know, I am a line. This is a line. Sometimes you'll use it like this if you have to. If you have wires that are running, you know, 500 feet across your screen, and you're like, what the heck did you come from? So you build it like this, and then if I have something else, then I do it here. So I kind of, it's the label that travels with the end of my line, at the end of the kind of connection wire. The other way you use it is just for storing inputs. You know, before you can go ahead and we'll do one more line that we'll build. So let's do control copy. We'll paste that guy. The copy is great because it's easy, but it also makes it with the things that it was connected with. So you can do like we talked about, you can disconnect. If you grab it from, the other way to do it is to build it, you know, grab it from the toolbar. So let's do that as well. Actually, yeah, that's fine. We'll just do the one. That's all we need. But if before when we did this, we right-clicked, said set one point. That was kind of a one-way thing. It was just stored inside this line. So this is a way that you can build if you use param and you do a point. And I'll do a couple of them. And these are giving us this warning, you know, orange is something's wrong. It's telling us that I'm empty, there's nothing in here. So we'll do this, we'll set 1 point each. Grab that. Grab another point. Can't see all my points. Can always highlight here and see what's real and what's being made from Grasshopper. We'll do one last one. So here, I'm going to hide these for the moment, so you can also group select in Grasshopper. It's a little flaky in that if I right-click on something, it still only does that one thing. So if I do this and I toggle the preview to off, it only changed that one. If I right click in the middle of anywhere after I've selected. Now I'm doing this for the group, and I'm going to go ahead and say preview off. All right, so now we're looking at this line, this point, this point. So now I can do the same thing where I drag these here. And the advantage here, this is only slight, but as you start to get into the hundreds of points or something, this is where if I copy this, I could say, okay. So I did a control copy, control paste, left those connected, but let's rewire this one here. So now I'm using this point twice, and I only had to select it once. If I want to change it, I can say set one point. And now both of these are replaced. You could do it the same way where you were doing it right at the input line, right at the A where we were set one point before. So right now those options are hidden because the wires are overriding them. But this is the input box that lets you store those. Does that answer that question about the line and the point? All right, so where were we going? So there's a couple different things that are different in that this program is also built for architects and for 3D modelers from the ground up. And there's a lot of things that aren't just kind of one-off topology. We looked at under here, these are very much like what we were looking at, the tools that were in Digital Project. The planes are very similar. But there's also ones where they're like, it's more, instead of being just a screwdriver, it's kind of like the whole toolbox. So some of the tools that you also find are a combination of things, and they'll have more complicated boxes. So let's take a look here at just square. So square grid here has 4 inputs. Plane, it has a default value. Some of these boxes come in empty and they start out as orange, kind of like the line tool. The plane or the square grid comes in pre-populated, so it has the XY plane. This is grid size. This is number of cells in the X direction and number of cells in the Y direction. So this is very small, but it's that little little guy down here. And actually, oh, I forgot. There's one other piece before we leave our lines. Sorry, that was where we were before we did these guys. Let's go ahead and unhide these. Go back before we get, because we'll need them right away. So group select all these if they were hidden, and preview on so we can see our lines again. So we were saying that these, even though they're parametric, these guys are kind of lame because we can't do much with the points. In the we talked about these are the boxes to hold things. The other components are the things that do things. And there's all of these that are just in these 2 piles here that are, so I'm under params, inputs, and utilities. These are all ones that are just weird and do something different that isn't in that category. One of them, and the one that you use a lot, is a number slider. So I'm going to go ahead and select that guy. You can also, again, if you can't find it, you can double click on the canvas, and if you can kind of remember the name, you'll get there. Although you start to get lots of stuff. So and slider, what it can do here, if we, it's got an output coming out the outside. So here's that point there. Let's look at that one. It's 10. let's drag it to the X here. Now I have this live manipulator for my X value. 0 to 1, that's also kind of boring. You can double click on the word, or the number, sorry, and you can enter it if you need to be very precise. You can also double click here on the gray part, the label, and this brings up the definition. It's a lot more complicated looking than it is. Really, you're just setting how much variability I want to give that slider. So I'm going to go ahead and leave the min at 0, change the max to 10. If you mouse over these, it'll tell you what they mean. You can set things for even numbers, odd, integer numbers, and then this value controls the decimal point. So I'm just going to go ahead and drag it to 0. You can also click there, and it does the same. So now I have a slider that will go from 0 to 10, and will only stop at whole numbers. And so where this is kind of nice, if you think about the example we did last time, there was that parameter that we didn't ever tweak in Jonathan's definition, which was the maximum depth of those metal panels. And so, yeah, you can keep typing it in, but sometimes it's nice when you have those kind of parameters. You really want to tweak and see the effect to add these sliders, and then you can change them in real time. So there's a couple other things in there that aren't exactly something that makes geometry. We'll come back to some of those later. So, all right, so back over to this. Let's go ahead and hide, group select those guys, preview that off. How are we doing on time? Great. All right, so let's make something that's more relevant to maybe a project in an architectural context. Let's start with this guy. This is the square grid. I'm okay with leaving it, so it's going to be based at the XY, which by default is at 0, 0. Let's go ahead and set this to 3. We'll assume they mean 3 inches. And let's go ahead and do 100 and 100. All right. So yes. So I'm right-clicking on the EX and the EY, set integer, and typing in 100. And I did the same on the spacing, set number, and I set it to 3. So in terms of the visualization, so what you're seeing here is everything that lives in this box. So there's a couple things to look at here. So on the input side, it's showing us, it's not showing us any numbers. Those are non-graphical in terms of Rhino. But it is showing the plane. This little guy right here is the plane visual. So the analog is just that white box in Digital Project. You get the little grid here with the red and the green. That's what we're looking at there. And then here's my grid, my 100 by 100 structure. So I mouse over the outputs. I have points at all the grid corners, and I have the cell outlines. That's what you're seeing here, all these boxes. I only care about the points. Let's go ahead and go up to the params menu and grab point. Since it's all contained in this box, I can't really just look at the points, so that's where this is handy. So I'm going to pull the points over to this. There's all my points. I'll go ahead and preview off that. Now I have just the points showing. Is that working for everybody? Let me know if there is if it isn't for anybody, because we can pause for a moment and I can get anybody back up to speed. All right, so this, let's think about this in terms of thinking, we'll do some manipulation of this for a perforation pattern. And we'll go over a couple different ways we could maybe manipulate and create this 10 by 10 installation, or 100 by 100. So we're talking 300 inches. Maybe that's too much, but yeah, whatever. It's sort of unitless at this moment. So we have these points. So in order to give it that sense of the perforation, let's start with creating the circles. So I'm going to go to Curve. Under Primitives, I have, where is it? Circle. All right. So Circle's input is points. So we'll come back to this, but this has kind of got a big, instead of before when we were looking at the outputs, they were very sort of logical. That's one line. This was 2 points. I could see them there. Now I'm starting to get some, I don't know, some craziness there. We'll delve more deeply into this later, but what this is doing is it's keeping track of, if you needed it later, kind of the grid structure. So it's saying you have 100 by 100 items, and if you really cared about it, you can go to the exact, I want to know where exactly point that's at 27 and 25, and you can pull that out. For now, even though it looks weird, it will still work. We don't have to mess with it, but that's why that is the way it is. So we'll just drag this over to point. So we said our spacing here was 3, radius equals 1. Go ahead and turn this preview. This is where sometimes I do this toggle, because it's kind of a pain to be turning off and on everything all the time, but you're usually caring about what you're doing with the moment. So I'm going to do that, the draw only preview for select objects, and we'll look at our circle. Okay, so the grid's 3 by 3, the radius is 1 by 1, so I can adjust that. Let's set number 2. Looks cool, not exactly perforable if you're actually drilling all those out. So the maximum, just by doing the math, is going to be 1.5. Again, if you want to kind of look at that, play with it, if you double click slider, you can set that there too. Minimum range 0 to 1.5. We'll set it just to 1 decimal. Drag that there. This is another one of those distinctions where there's a little more velocity to the manipulation and a lot more fast feedback. We're not doing anything that complex, but there's a little bit more, there's a simplicity to the data structure in Grasshopper where you can see that visualization change very quickly. It helps a lot when you're in the design phase where you're iterating and you need to see the effects of how you're changing parameters. The other thing that becomes, so part of that, the reason you have that velocity is none of those are changeable. If you were to do the same thing in Digital Project, you'd actually have a physical circle at each one, and you could go back in and you could say, actually that one, just that one needs to be 1/4 inch. Here, it's all or nothing. You can do some, well, the next thing we're going to do is to build a system to do that, but But in the end, if you just have that one that you need to do something special to, you know, that's where the conduit has to go through this panel from the lovely electrician that's going to be retrofitting my space, then you have to do that sort of off the parametric grid. So advantage, speed, flexibility. Disadvantage is less specificity when you get to the individual items. All right, so very simple grasshopper definition. Just a few points here. 100 by 100 grid and very linear adjustment. So there's lots of different ways to manipulate this, and we're just going to start layering those on top just to start to play with something that's a little more visually interesting. This is available at the store, but we want something custom. So I'm going to go ahead and delete this guy, because where we want to start with our variability is this radius. So I'm going to go ahead and turn back off the only preview. Go ahead and hide this. Just leave my circles. One way to deal with creating adaptability is the attractor. And the attractor is the idea that I can put an object within this grid, and that object will affect things in the way that I define. And so what we're going to say is that this is the attractor. Items that are close to this point will have a larger radius than the ones that are further away. So I need to bring this point into my grasshopper definition here. So we're going to go back to params. Remember, these are all about importing and holding geometry. That's what they do. So I'm going to grab point, drop it down here. I'm not going to make you rename everything, but I'm just going to show you that you can. If you right click up at the top, you can rename anything you want. It always starts as the default of what it was, so this is, I can call this a tractor point. Tractor point. Eventually you'll have so many things in your model that you will be happy that you labeled that, and then you will be able to understand what you were doing 2 hours ago, but we don't have to do everything. Also, the danger is that you can change things and make them really hard to figure out too. You can always mouse over and see what things are, but the label there. One other, just again, while we're talking about figuring out what things are, if you come here under display, there's a couple different things you can toggle. And the examples you'll find online, people have different preferences of how they save their files, and so when you open them, those will remember sometimes that visualization preference, and you'll be like, what is all of this? So if you toggle here and you say draw icons, it changes all of the labels to the icon. And again, sometimes the icon is just as mysterious as the very terse label that they came up with. So you can say turn that off. There's also draw full names, which is great, except it is sometimes makes havoc in what you've laid out, because so draw full names is the sort of most user-friendly. This is the introductory way, except it makes them huge. So all of this nicely clean and organized structure, once you start doing the full names, so they don't stay in the same place. They all stay centered where you drop them, but they start to overlap each other. So usually I don't have those on. If you have them on as a default, then you won't have the problem of things overlapping because you won't be putting them on top of each other. But if you guys encounter that, mostly what you'll encounter, I don't think anybody actually does too much of that in the files you'll find online. A lot of people though have these, and I don't know. For me, I do it with the label. It's because how I started. It's just as mysterious, but it's what I know. We'll go from here. So we have our attractor point. And so now we need to think about and how we relate this point to the other point. And I said what I wanted this point to do is, by distance away, affect the radius size. The closer it is, the larger the radius. So I have my points here. If I go back to my preview mode, here's all my lovely points. So there's going to be this idea of constructors and destructors, and lots of things you'll find. If we go back to vector, we'll come back to points and see what's available here. So we used the construct point before, and that was giving it the XYZ value, and it outputted the object. You also have deconstructor here. So I can start to look here. I'll go ahead and just, for the moment, we don't need to. This is a big list, about 100,000 points, it's telling me, or 10,000 points, and that'll be all the X values. So you guys know the math behind doing, at some point you guys had to do that. We don't have to do this tonight, but behind the scenes, the XYZ, and there's all that fun stuff. If you really wanted to, you can do some of that, and sometimes you have to drop down into actually manipulating the numbers and doing some of like the point slope or other those. Luckily, half of the stuff we want to use is already built in. So if I go back here, I don't even know where it is. I want to know the distance. So I'm going to go ahead, double click, type in distance, see what it gives me. If I mouse over, that looks good. Compute Euclidean distance between 2 points. Probably that's under point. Yeah, there it is. Usually things will be where you think they are, but lots of times it's just as easy to double click. So here's where things get interesting. So distance. First point, second point. It's talking about it in the singular. I don't really want to make 10,000 of these boxes. So we talked about this data structure before. It's keeping track of all of these. This box is, it tells you there, it's got 10,201 values, because that's 101 times 101. This guy, empty point. Sorry, forgot to do that. So we want to go ahead and connect that. So we're going to do right click, set one point, go ahead and select that. There we go. So it's now live in Grasshopper. So what Grasshopper is really famous for is it does all the hard work for you when you have some of these really weird many-to-many or one-to-many or a bunch of things where 100, you're already at quite a lot of data just with this simple box. So I'm going to go ahead and drag from point to A, from an attractor point to B, and it lights up. And it tells me it has 10,201. Just for a moment, because right now it's still a mystery. It's just showing us this kind of structure. Let's go ahead and do something just to visualize. So this isn't going to change the data, it's just going to change the way it's showing us. I'm going to right click on the P on the output for the square grid, and I'm going to do flatten. So it says flatten all the data in this parameter into a single list. If I do that, mouse over it, okay. So now I've got, this looks more like point data, XYZ, XYZ. Apparently there's a lot of them there. When I mouse over, I'm starting to see that Now here, that structure, that single list keeps going, because I've already flattened out that kind of more complex data structure. Now I have my distance. So again, it's telling me I have 10,201 values, and there's my distance. So right now what this means is things that are really close are really small. Things that are far away are really big. If you just drag this here, we can kind of see what that looks like. Not very helpful. So that's not it. Disconnect that. So we need to make this, start to manipulate this so that it works within the scale that we're talking about. So I'm going to go ahead and come and find math. Because I did that, the circles I looked at, you know, they're massive. They need to be much smaller. So we'll use divide, and we'll divide that by a value. Math has a bunch of different things about dealing with evaluating what you have. You know, this is something that we can look at right here to make some judgment. Under domain, there's something called bounds. It says min and max. If I drop this guy here, drag it, gives me some information about all that data. So I have 10,201 points. The smallest is 0.4 and the biggest 299. So let's grab our divide. Operators, there's a lot of math operators here. We're going to say integer division. Because what's coming out of here, if you look, it's a distance, it's a number. Drag that here. Let's just go ahead and say 200 and see what happens. I can re-evaluate this, drag that over. Now my bounds is 0 to 1.
Where did you set 200 at?
Sorry, right click on B and you can set the integer there. And actually, sorry, I grabbed the wrong box. There's two divisions, we want division. Dramatically different. All right.
Which division?
You want the just plain old division. That'll leave all our decimals, which is good. Again, set the value for B at 200. And I can drag this bounds block over and it's telling me, okay, now I'm running from 0.02 to 1.5 approximately. So let's drag that up to radius. So because the data that's coming out of point, I'm doing the manipulation. The order is staying the same. The first distance evaluation is, you know, from this point to whatever corner it starts at. And so later when these strings come back together, there isn't some confusion. It makes sense that the smallest ones and the radius value that was evaluated is matching back up with that point. So this is starting to look, you know, different. At least it does what we wanted it to. Actually, did I say I wanted it bigger? Well, this one's smaller. The closer it is, smaller. And as I drag around, this definitions is going to evaluate. So this stays the same, this stays the same. The distance, the divide, the circle, all those are going to reevaluate as I move that around.
What's the bound?
The bound is just giving me information. It's telling me what is the highest and lowest value in that list. So when I first ran the distance formula, you know, I can kind of see a few values there. and I can guess because I made the point, but that tells me exactly. You know, the shortest distance is 1 and the largest is 300.
The purpose of the deconstructor so that all the circles can, I guess, alter differently.
Oh, the point of the deconstruct, we may come back to this, but the point was just that they made it easier for us. You know, we didn't have to go to the chalkboard and do the point, slope, point, distance, you know, whatever that is, square root of x squared minus xb. So we can delete that. That was just another place where there's a lot of functions, especially whenever you're looking at all of this analysis tab. There's a lot of stuff where it will just give you the information that you're looking for. So start there before you start building kind of some of this more back to geometry math manipulation.
Why did you flatten there? Is it necessary?
No, the only reason I flattened is so we could actually see that data.
Oh.
So here you can see their points. So if I unflatten this, nothing changes. It behaves exactly the same. The difference is that it's kind of keeping that data structure. Later we'll have times when we need to use that and take advantage of it. Right here, it doesn't hurt to flatten this. It just shows us, because right now you can't see past. The only thing it shows in the screen is just how it's creating different lists of those data. And what it does here is it's basically storing the information row by row, if you cared later to go back row by row and affect it. So I'm going to leave it flattened here, right-click, flatten, just so that it is visible. All right, so we got our circle. And we got our single manipulator. So you can also start going and doing some other things. You know, if you start doing sliders, there's a shortcut. Try to remember if I can do it. For making a slider, like, so we know we did EX was 100. So if you wanted to make a slider that was 0 to 200, you can say, I think it's 0 less than, you set your default value, so let's set it at 100, less than 200. So if you leave it like that, it's set up and you hit enter, it makes a slider for you that's like preset at that value. So you can drag that here. Now I can stretch. And you can see where it starts to chug. You know, eventually it starts to get mad at you for making lots of data. Very quick down here and chunky. So you can copy that one, paste that one. And one thing we notice here, so it still looks good here. I got my little points. But if I zoom in up here, this is non-fabricatable in our imaginary, you start sending the mill over to drill those holes and there's nothing left when you're done because it's removing all of the material. So let's do a little bit of work here in filtering this value. So maximum. If you want to find it in, it's all under math. Lots of the stuff we're going to use right now is under math somewhere. So if you read the description of math, it says returns the greater of 2 items. Is that what we want? Actually, sorry, minimum. We want the minimum. I think we did this with the digital project too. Okay. Double click, minimum. All right. So we're going to drag our result of the divide in here. And let's kind of link this up because, you know, I can type in the minimum radius here, but if I change it here, then I'll have to come over and right click. So let's go ahead and make another slider. So let's do this one 1 to 5. So again, if you don't want to define it on the fly, and that's always, let's see, how's it work? So it's always less than, so if you say 1 less than, and we'll say our default is 3 less than 5, depending on how many decimals you add, that will also set the since we did the first one at just an integer, it set it with no decimal. If I do 5.0, it will set the value of the adjustment to the nearest decimal. So let's go ahead and drag that there. And now we have a little bit more flexibility, but we want it over here too for our minimum. So drag it there. Now these are one of the examples where, I don't know, depending on how much you care, you can start getting wires on top of wires on top of boxes. I'm going to go ahead and just right-click on that input and do hidden. Once I unselect the box, I get that radio symbol. If I click on minimum, I can see what it's actually connected to, but it doesn't go over my... So everybody into architects, you have to have layers and layers of design sense. So even your Grasshopper definitions have to look nice. But
Where is the minimum connected to?
minimum right now is connected to that new slider. So, because what minimum is going to be is related to my radius. And so if we go back to our square grid definition, so it had the initial point where it started, the 0, 0. And this was the spacing of the cells, or the spacing between the points. So actually the relationship here is that the minimum value I want for my circle, since it's a radius, should actually be half of this grid size. If it was the full grid size, it would go from point to point. Again, something your tool path wouldn't work. Your tool will just drill out the material. So let's finish wiring this up. I'm going to drag this over. Drag that up there. Alright, so what I should see, I'm still not exactly right. This needs to be half. Right now it's 1 to 1, so my minimum circle will actually be at the furthest point away. If I drag this, way up here, I should get circles that are just, perfectly wrong, but that's right. So we need to divide by 2 to get it to radius. There isn't a circle divided by. There is not a circle really defined by diameter. So we want to change our value that's coming out of here. There's a couple ways you can do it. You can just divide by 2. Come here. I'm going to set data for the second item. Commit change. And I'll go ahead and drag this up. Okay. So now all my circles, the maximum, still not ideal, but that's sort of in the ballpark of something that the mill could drill out. The other way to do this, you don't have to do this, I'll just show you as a help. So I'm going to copy and paste the circle just to get a different one. I'll go ahead and disconnect there. I'm going to come back to my minimum here. So this is where we were a moment ago. Each of these parameters has this lovely expression, and so if you do know kind of some of the syntax you might use in Excel to write formulas, you can do formulas here on the fly. The way the syntax works is it knows the number, or the label. So this is R for radius. So if I said R divided by 2, commit change. It's going to take every R value coming in and it's going to divide by 2. Sometimes, like right here, maybe we want to say R divided by 2 minus a tiny bit of clearance. So we leave some material when we drill out our holes. It's a little bit more complicated. You could do the same thing here. Divide, you'd add a subtract. both ways work the same. It just depends on how many boxes you want to put in. Sometimes you'll know a formula or a way of manipulating this, and it'll be 6 or 7 mathematical functions, and you can just kind of embed them there and just not worry about the series of boxes that will drag across. So both ways are valid. You definitely can see what you're doing here. Sometimes you have to remember what's going on and know what the asterisk means here. All right, so now we have our more parametric wall. We can adjust the spacing slowly. And it's still all linked. I'm going to go ahead and move these just away. And shrink up the size. And I still have this one physical object in Rhino that's manipulating all of this geometry. And you have to be careful too, because if I go ahead and delete this, the whole thing stops because it's all based on that point. And so these all stop evaluating. It says null, there's no distance between points and no point, but Control-Z usually works if you accidentally delete things you cared about. So let's go ahead and save this guy. Save this guy. So everybody's working like this.
On your track.
And the one value that's in here that we could also, it's kind of just a plug value right now that you could manipulate that affects sort of the strength of this, is this guy. In the very beginning when we were more static, we said 200 was the right number to divide by. So let's go ahead and copy one of these guys up here. That's the 0 to 200. If I copy, paste the slider, drag it over here, and I pull it into B, what this is doing is it's changing the strength of that attractor. And if it's running slow, you can dramatically increase performance by decreasing your kind of number of points. So I'll do that. Oops. Drag this back over. So the strength of this attractor point is individually kind of controlled by that that value here. Okay, so now we have 1 point. You can also then say, what happens if I start to mix and match some of these? Let's have multiple points. So I know that this part here, actually just these few. So this is the part of my my function that evaluated that. This guy just does the minimum between those two. go ahead and copy paste this. And you have to grab, when you have multiple items copy pasted, if you want to grab them and move them together, you have to grab onto something that's one of the objects. Then you can move it around. There's also something here, all of these. Don't do that. If you grab and select grab anywhere else, it will kind of disband. And so if you do it and it's on top, you'll have to pull them apart. So I would just Control Z if you do that. So, all right, let me get back up here. Copy, paste. All right, so let's go ahead and come over here and drop in another point. And I'm going to redefine the second attractor point. We'll call it second. You right click, that's the top line there. I'm going to set one point. I already had it selected, so it immediately selected that guy. So it's still not doing anything. It's doing the evaluation, but I'm not doing anything with that value. I'm going to make some space here, drag it over. So now I want to do some valuation between these two. The simplest way is just to grab either the maximum or the minimum value. We can try, let's try maximum. It's probably supposed to be minimum, but we'll see what happens. I'm going to wire up A and B, and we'll see what this does. So if I drag this over onto A, it's going to replace it. Looks like it kind of diminished the behavior except in the middle. They're independent now, so I can change the strength of each one independently. Let's go ahead and make a minimum instead. Double click minimum. Grab that, wire it there, grab that. Pull it to A, delete. All right, so a different effect. But again, the strength is controlled there. But you can see now that a lot of what we've done is we just said, well, let's play with this, let's try this. It's very easy to use this visual programming style to redefine your definitions. You can see the way the logic's flowing. That's the whole point behind the strings, the wires, whatever you want to call them. And then they're very simple to redefine and pull apart and move around. You could conceive of doing some more. You might have some other ways that you might want to do it. I think if you want to make one of them sort of a detractor or the opposite, where is it? You reverse the streams, you go up here, you go down. Probably have to scale this a little more differently, but now the behavior of these start to act differently. And you move it around and you can see the result. All right, so let's do, in the last few minutes, go all the way back. The other thing is, all of this is interchangeable. We said we wanted a circle. I'm going to go ahead and delete this second one here since they're right on top of each other. if you go back to curve, the where is it? Primitive. There's some other things in here that are other than circle. Let's grab rectangle. Point. X, Y, and the fillet. So I'm going to leave this at its kind of basic at the moment. So this is a little different sort of, if you look at it, it's not just a value, it's a domain. They could have done a couple more boxes and added, 7 more things, but they put it together. So we'll leave it right now. If you just drag point, so that doesn't work, why doesn't that want to go? If you want to move things that are already connected, the key combination for the wire adjustment is Control-Shift. It turns dark arrow, and then when you grab it, you can move things at the end. The other way to do it is to pull it from its start, from the start, and then you could redo it. So now I have my rectangles, because they are defined by default -1 to 1, -2 to 2. I want to make these square, so let's go ahead and do those. The place where the domain definition is hiding is under domain, under math. There's construct a domain. So what this does is it takes those two values and puts it in that format. The negative, in this case it's a 0 and a 1. If I drag this up to here and down to here, I get my squares. Those were the default values that came in. Let's go ahead and, what we care about, because in this case the analog to the circle is that the radius changes. So let's connect our value that we were grabbing for radius and give it to our lengths here. We can leave it at 0 and just drag R, the result, up to the B for the domain. Now I have square pegs following that kind of similar. I'm going to go ahead and change these back. So I switched these before to make it a detractor. To reduce that. Oops. And depending on what you're going to do, this might work great. If I go back and I am going to also turn on these points and see where they are, I think I'm at the bottom right-hand corner. Yeah, bottom left-hand corner. If it matters, if it doesn't, that's fine. If you need it to be at the center of your point, if that's going to matter for something you're going to do later, you can drag this here. That didn't work because now it's, the same to same, so this is 0 distance between them. So I can use my expression method here. Right click on A, and I'm going to say negative A. So it's going to take every value coming in and make it negative. I'm going to hide these again because you can see they're at the center. So the thing that's fun about just playing with these sort of math and manipulations is you can start to just chain together certain things. So right now what we really are playing with is scale. Scale is the size of the whole. But you can also do rotation. Rotation is another transform. So let's go ahead and build a similar sort of functionality to do some rotation. I'm going to go ahead and click another point, drop that in there. Grab this here. These are my 3 that I'm using for manipulating that data coming in from the tractor. I'm going to copy, paste, drag that down. We'll call this one rotation point. There's a couple things you could do here. I'm just going to leave it distance because we got a couple minutes, but you could evaluate the rotation, the distance between a line, and there's lots of different ways you can take this, but we'll just stay here kind of in the same way that we've done it before. So I have a result value that I'm scaling to give strength to. But for rotation, I have to do some manipulation. I can spin it, 4,000 degrees, but that's not that interesting because it's the same over and over and over again. So let's just limit our rotation to 0 to 180. Does that even make sense with a square? Maybe only 0 to 90 because it's a square. So there's only a difference in that small range. Once you get there, you're just doing the same thing. So here's where that, originally we pulled out this guy here under math, under domain, there was min max. So if I look at the values coming out of here, they're at, kind of see it there, 0.0 blah 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 to 90. So I'm going to take this, and what I want to transform this to is from 0 to 90. That makes sense to me. So there's, in the same domain tool, there's something called remap. We'll actually use this a lot. Because what this does is it says, okay, take all these values. So remap is remapping numbers into a new domain. All of this is all very happy math speak, but what it means is it's going to take these values. Here's my source domain, and I'm going to say my target domain. So my source domain I just measured. That's what this is. That is domain being the minimum and maximum values in that list. Pull that up there. Target domain. So you don't have to build these. You can right-click, set domain. If you screw up and delete the 2, it won't accept it. But if you kind of type it the way it is written there, it will be happy with you. So we can say 0 to 90. And what that means is that everything that comes in is going to be sort of scaled to the appropriate value within that range that's 0 to 90 now. We're short on time. I'll draw some stuff to illustrate this next time when we start using it more. But you can also check it. Copy paste the bound. If you drag that here, it should be 0 to 90. Okay, so everything in there got scaled and it's within that. All right, rotation. So all of this stuff is under transform. This will be our last piece today. So transform, pretty much everything that we've used, you guys used in Rhino and AutoCAD, all happens under Euclidean. We're going to do rotate. I think it's rotate in a plane. I think that'll work. All right, so base geometry, angle, radians. Oh, crap. Luckily, I think it's degrees something. Maybe it's radians. Radians. Ah, yes. Mouse over there. Convert angle specified in degrees to radians. That's what I want. So this was 0 to 90 coming out of here. So I'm going to go for my remap output into radians. Now that's something else, radians. So that's my angle. G, the geometry. What am I going to change? So I'm going to pull this back here to the back because the last thing we did was rectangle. That got my scaled holes. Rectangle, or what's this called? Row rectangles. Yes, that's what I want. So those are the geometry items I'm going to scale. All right, that's cool. Let's leave it like that. So this is the result of everything's rotated around the 0, 0. But that's kind of cool, and it's responsive. If you move this around, Or not. What did I do? Hang on. Ah, at this point. Okay. There we go. Oh, I forgot to remap this. It's connected to my... Okay. Set one point. Apparently I didn't change this one. There we go. Is that right? No, still didn't do it. So I want this one to be that guy. There we go. Okay, so these are still my attractors. They're changing the scale of the hole size. This one, change the rotation. That's sweet. That's not exactly what we wanted. We still have this piece of wood we want to cut on. So the last input here is point. So that's all the way back up here. So we just want to drag that, connect it there. We got both. All right, so preview off on the rectangles. All right. Kind of got to be zoomed in or have a little bit bigger screen than I have here, but as you move these around now, you're going to get local movement. Last thing is kind of fun in terms of the behavior. You know, we set this point at the center of this square, so it's all rotating about the center. Everything's happily still in the grid. If I come back up here, you don't have to do this if you don't want to. You can disconnect that guy. And if you get these a little bigger, you'll have a little bit different effect now. Let's see, how do we do that? So we don't care about this. Change that to 1. This should make it bigger. There we go. Depending on how you kind of subtly adjust the point at which you're rotating, you can start to get some interesting effects. You know, you could even offset this to times 0.5. I don't know. Point is, you start to play. Once you have these, all of these points are just, all of these boxes are departure points to look at different ways to manipulate the geometry, and in this case change the perforation for the piece of material you're going to cut on the mill. What we'll do in the next couple weeks is take this, you know, and one thing, the main assignment I have for this week, so we'll get done on time because it's about 1,000 degrees in here. Take a look at what's available out there. The main website to start with, if you have any question, is Grasshopper 3D. It's the website run by Rhino. Pretty much everyone is asked the question that you have. How do I? And you type the thing, and there'll be 70 people answering it. Some of them will be bad, some of them will be good. There's stuff, usually you judge stuff by date. If it's from 2006, look for something a little more recent, because about half the functions that are in here now didn't exist 4 years ago or 6 years ago. So go ahead and do that, and then pick something that is, you know, it doesn't have to be, you know, this definition here is, you know, it's got a lot of sliders, but, you know, it's 16 boxes, maybe 16 components. Pick some piece of algorithm that you want to look at. Try to find that helpful description online and build some piece of that small manipulation. The main goal is just to see what's out there. Like I said at the very beginning, there's a fire hose of tutorials and websites and posts, and everybody posts their files. Everything you'll find in Grasshopper 3D is, oh, here's the Grasshopper file with the things. They'll show you the picture of it, and you can drop it in. And in terms of learning, it's a lot easier because everybody has. It's always easy to learn by example. Digital project does not have that, so we should be able to make a little bit more progress getting where you want to go here in Grasshopper. So what I want, the other piece of it is, from that example, you guys kind of create the agenda. I'm going to do next time, but I'd like the last 2 classes to be by the end of next week, I'll give you a list of different ways and different things we can look at. Grasshopper has a bunch of different ways that you can manipulate surfaces. You can do sort of optimization things that are, if you have a surface and you need to make it kind of fit different constraints. So let's go through some of the choices we have, and then depending on what you guys find and what you guys build, let us know what's applicable to what you're doing in studio. Let's make our kind of agenda for the last 2 weeks based on that. Any questions? All right. Thanks, guys. I will post the video and the file, this one that I did, tomorrow.